In this video, we'll cover how a furnace works and explain the various components, including the different types of furnaces that are used mostly in residential spaces, but also used in various commercial applications. Natural gas is the mostly used fuel for furnaces. We'll explain the difference between a condensing furnace and a non-condensing furnace. We'll discuss how furnaces are rated for energy efficiency and the type of flues used for each type of furnace. Construction of a furnace. The furnace can be installed vertically or horizontally in a closet, basement, attic, crawl space, or equipment room. The furnace is housed in a sheet metal casing. The latest models use a variable speed fan to blow air over the heat exchanger. These types of fans have direct drive ECM motors that are much quieter and run more efficient than traditional fans. The fans don't handle a lot of static pressure, often a maximum of 1-inch water column, 0.249 kPa. Gas piping will be installed from the gas meter or from a branch off the main gas line and connect to an internal gas valve and manifold in the furnace. A gas shutoff valve should be provided at the furnace for isolation of the gas. The shutoff valve needs to be in a visible location close to the furnace for ease of use in an emergency or for maintenance. Between the shutoff valve and the furnace should be a union and a drip leg. The union provides for the gas piping to be removed from the furnace if required. A drip leg should be installed to trap any condensate in the gas piping and prevent it from entering the furnace. The drip leg should be located away from where it could freeze. After the piping is installed, it will need to be pressure tested to ensure there are no leaks. The pressure test can be done using compressed air or an inert gas like nitrogen. Never use oxygen to pressure test gas piping. The use of an electronic leak detector can help identify any leaks indicated by a failed pressure test. Obviously, a flame would never be used to find a leak. Pipe size depends on the volume of gas required and the size of the furnace, but for a small residential unit, the gas piping might be just a 1/2-inch, 20-millimeter pipe. The gas valve controls or modulates the flow of gas to the burners. The burners convert the fuel and air into heat that enters the heat exchanger. With a condensing furnace, there will be two heat exchangers, a primary and secondary heat exchanger. With non-condensing furnaces, there is only one heat exchanger. The heat exchanger is where the room air absorbs heat from the burning fuel. By having two heat exchangers, the condensing furnace allows for additional heat transfer and lower flue gas temperatures. The secondary heat exchanger will most likely be made of stainless steel to prevent corrosion, as condensate will occur at lower flue gas temperature. The combustion air will go up through the heat exchanger and to the outdoors, while the blower fan sucks in return air and blows it through the heat exchanger, then out to the spaces to be heated. The air delivered to the spaces and the burning fuel with its combustion gases are on opposite sides of the heat exchanger wall and never encounter each other. Some manufacturers provide removability of the heat exchanger for easy serviceability. Combustion and flue exhaust will need to be provided. With a condensing furnace, this is accomplished by installing a combustion inlet pipe to the outside, direct venting, or inside, non-direct venting, and a combustion flue exhaust to the outside. If using a condensing furnace, then vents can use 2-inch to 4-inch PVC, as the flue gas temperatures are much lower on these types of furnaces. For non-condensing atmospheric furnaces, it's common to use B-vent. Check the furnace manufacturer and local code authority for venting requirements. There will be a direct spark ignition or hot surface ignition system for the lighting of the gas when heating is called for. Along with the direct spark ignition is a remote sensor that confirms that the gas is burning. This is a safety device to prevent gas from being released if no flame is sensed. A condensate pipe will need to be installed for any condensing furnace installed. Condensing furnaces are more efficient, but the byproduct is condensate that needs to be routed to a drain. The drain will have to run through a neutralizing filter because of the acidic nature of the condensate. This neutralizing kit can be provided by the manufacturer or bought separately. Newer models will have integrated circuit control boards that could contain dip switches for easy setup adjustment. Electrical conduit and wire will be run from the breaker panel to the furnace. These furnaces require only 115 volts, single-phase power to the unit. Inside the unit should be a transformer that reduces the 115 volts down to a lower control voltage. There will be a safety switch on the cabinet door leading to the blower so that when the door is opened, the blower is shut off. This prevents someone from getting injured from a moving fan wheel and motor during service. Filters can be provided on the bottom or side inlet to the fan housing by adding a filter rack if one isn't provided. Remember that the furnace should never be run without a clean filter in place. Thermostat. Look for furnaces that have some form of communication with a smart thermostat to provide system information and alerts to system problems. There are also mobile apps that allow for notification and setting adjustments remotely, including routine maintenance alerts. The thermostat should allow for modulation of capacity. There will be a control wire access port for the thermostat wiring coming from the conditioned space. When a thermostat sends a signal to the furnace to provide heat, the combustion air fan will start to ensure proper air for the combustion of the gas. Then, to confirm that the combustion fan is running, there is some form of pressure switch that picks up pressure created by the fan, which then energizes the hot surface igniter. After a preset time, the hot surface igniter will allow gas to flow to the burners. After another preset time that the burners are operating, the blower fan will start and blow air out of the furnace into the space. If the system fails to light, the burners, after various attempts, then shut off the system and contact a service company to determine why. Thermostats often allow for two settings. One is auto, which lets the system cycle on and off to meet demand. The other is fan only. With this setting, only the fan runs continuously without any heating. If adding a split system air conditioning unit to the installation, the DX coil will mount on the discharge of the furnace and share the same fan for airflow. The furnace can weigh from 100 to 200 pounds depending on the heating capacity of the unit. Carbon monoxide detectors. With gas furnaces, there is always the chance that the heat exchanger will leak and bypass air into the occupied space. This combustion gas is poisonous and could cause headaches, dizziness, weakness, upset stomach, vomiting, chest pain, confusion, and even death. Remember that carbon monoxide is odorless, so you won't smell a leak. Therefore, installing a carbon monoxide sensor is so important. Also, carbon monoxide can't be seen as it's colorless. It also can't be heard, so your own human senses can't be relied upon as your eyes, nose, and ears won't detect anything before the effects of the carbon monoxide could be too late. So get CO sensors installed to protect the occupants. Safety switches. Safety is paramount when supplying a combustible fuel to an appliance that serves occupied spaces. There are various safety devices contained within the furnace to provide for safe operation, in addition to installation requirements for safety. Flame sensors ensure that the gas has ignited and that there is a flame burning. If the flame didn't light for some reason and the gas valve had opened, the space could fill with gas and cause a possible explosion. A rollout switch senses if the burner flame is rolling backwards out of the heat exchanger. The rollout switch senses the flame and shuts off the flow of gas to prevent a fire. A high temperature limit switch prevents excess temperatures from occurring. Excess temperatures are an indication that something might have failed or malfunctioned. The high limit switch will shut off the gas if the discharge air temperature exceeds the limit. The high limit switch will have to be manually or automatically reset. If automatic, then the gas valve will be reopened when the temperature drops below the limit. Operation and maintenance clearance requirements. Check the furnace manufacturer's literature for the clearance requirements around the furnace. These clearances are for safety reasons, such as preventing a fire from occurring to the surrounding construction materials. Clearances are also established for proper access to internal components for maintenance personnel. Furnace rating, AFUE rating. The annual fuel utilization efficiency, AFUE, indicates a furnace's efficiency. The higher the value, the greater the efficiency. You can find the efficiency listed on the front of the furnace as it's required by the Federal Trade Commission to be posted. The efficiency is given as a percentage, indicating how efficient the furnace is in converting the energy from fuel into useful heat on an annual basis. The annual fuel utilization efficiency is a ratio indicating the total annual heat provided divided by the total fuel consumed. A ratio of 90% would indicate that 90% of the fuel was efficiently converted into heat while 10% was wasted. This ratio is for the furnace only and not the distribution of the heat to the space through ductwork, as poorly insulated ducts will reduce the efficiency of the overall system. Check out our industry-leading estimating spreadsheets for HVAC, sheet metal and piping, plumbing, combo HVAC and plumbing, or residential HVAC and plumbing at www.mepacademy.com. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.